This presentation is brought to you by the SDG Decision Education Center.
Hello, and welcome to How Accurate is the Weather Forecast Anyway? Brought to you by SDG Decision Education Center and Texas Executive Education at the University of Texas. I'm Lynn Slattery, Director at Texas Executive Education and manager of a portfolio of open enrollment programs designed for busy professionals. This portfolio includes the Strategic Decision and Risk Management Certificate Program, which brings together the academic research and practical application teaching of UT faculty and 35 years of experience in strategy consulting and decision education of SDG, and serves as the basis for this webinar series. We are proud to be partnering with SDG on this series. Today, I'm excited to have Dr. Eric Bickel, an expert in decision quality, here with us to explore forecasting for better decisions based on his research in the area of weather forecasting. Dr. Eric Bickel is Associate Professor and Director of the Graduate Program in Operations, Research, and Industrial Engineering at the University of Texas at Austin. In addition, Dr. Bickel holds a courtesy appointment in the Department of Petroleum and Geosystems Engineering in the Cockrell School of Engineering. Eric, I'll turn the floor over to you to begin.
Thank you, Lynn, and good morning or good afternoon to everyone that's online. Appreciate you taking the time to join us. Today's topic, I think, is interesting and also a lot of fun. We're going to talk about how can we really judge if somebody is good at forecasting. And I'm going to be primarily focused on probabilistic forecasting. So somebody is assigning a probability to some future event. But really what we're talking about is more broadly applicable than just probabilistic forecasting. But that's the framework that I'm going to have. And we're going to demonstrate this in the context of weather forecasting. And that's something we can all relate to, and I think that makes it interesting and a fun topic. But even though I'm talking about weather forecasting, you should be thinking about how you could apply the concepts and the tools within your own organization. Okay, and at the very end, we'll talk just a little bit about how to apply this in business settings. I know you all have sent in some questions in advance. I'll try to highlight a couple of those as we go through, and then if we have time, we'll answer some additional questions at the end. This webinar I'm given today and the data in here, it's based on a paper that I wrote with a PhD student, Sungdae Kim, and then a colleague of mine, Eric Floor. We did some work with the Weather Channel and then published this study in Monthly Weather Review, and that's what Nate Silver picked up and then discusses in his book. So let's start out with a poll. First question is, how well does your organization forecast? And we've got three possible answers for you here. We have excellent, we always hit our forecast. Fair, we usually hit our forecast, sometimes we miss. And then poor would be we rarely hit our forecast. So if you would make a selection there, and we'll see how we're doing, and that'll help me decide what to emphasize as we go forward. So the votes are coming in here. Okay, we've closed the poll and sharing those results, and you can see that only 3% say their forecasting is excellent, perhaps not too surprising. About 2/3 it's fair, we usually hit it, maybe there's some room for improvement, and then about 1/3 is poor and we rarely hit our forecast. Okay, thank you for that. Let me ask you another poll question here. Does your organization keep track of its forecasting performance? So you're making forecasts over time. Do you keep track of those forecasts, and then do you look back and see how well you're doing? We've got yes, no, or not sure. Answers are coming in here. Close the poll in just a moment. Okay, we close the poll, and it looks, it's not quite, but it's about 1/3. Yes, we do look backs. That's fantastic. More than 1/3. No, we don't. And then about 20% not sure. Okay, so with that, I want to talk a little bit about how could we tell if somebody's good at forecasting? How would we think about quantifying that? Not as easy as you might think. And let's take a particular example. Let's say that you tune in to the local news, or you're looking on the web, and you see that the nightly weatherman says there's a 80% chance of rain 2 days from now. And we've got a little graphic here. As you know, they'll make forecasts from 1 to maybe 10 days out, temperature, but also precipitation. And here they're saying there's an 80% chance of rain 2 days from now. Now let's say, lo and behold, it doesn't rain. Okay, and we have a poll question for you. Was the weatherman wrong? He said there was an 80% chance of rain, but it didn't rain. Was he wrong? And we have 3 possible responses. First would be, yes, he was wrong because he said there was an 80% chance. Next is, well, he said there was a 20% chance it wouldn't rain, so no, he wasn't wrong. And then last would be, we can't say. If you make a selection there, I see the results coming in fast and furious. We'll close the poll in just a moment. And so with that, we've closed the poll. Small minority, 6% of us say that 80% chance he was correct. 57% say, well, there was a 20% chance it wouldn't rain, so no, he wasn't wrong, because he said there was a 20% chance it wouldn't happen, and it didn't happen. And then about a third of us say we can't really say. Right, and I think, so the question is this a heads I win, tails you lose situation? Somebody says there's an 80% chance of something occurring. If it occurs, they could say they were right. And then if it doesn't occur, they could say they were also right because there was a 20% chance of that. So we're in a little bit of a pickle, and the question is, how would you think about that? Well, we're going to introduce a concept that we call calibration, and I'm going to show that graphically. What we have here on the horizontal axis is the probability assessment. Again, we're talking about probabilistic forecasts. We could expand this to non-probabilistic forecasts. So here I have what the person told me. And then on the vertical axis, we have the actual success rate. And so our weather forecaster said 80%. We could track how they do over time. Imagine this weather forecaster said 80% on many, many days, and we kept track of that. We could then plot, well, what was the actual frequency with which it rained? And if that was 80%, if it landed here, that would be along this horizontal line, and we'd say that's a line of perfect calibration. So the person said 80%, and it occurred 80% of the time. Okay, here's another example where we had 50 forecasts, 50 different events, where probability 0.2 was assigned. If our forecaster is well calibrated, then those should occur 20% of the time. So you'd like to lie somewhere along this vertical line. If you deviate from that, then you would say, well, they're not well calibrated, and we can quantify to the extent with which somebody could deviate, and that we'd be worried about that. So that's the concept we call calibration. And let's apply that to the Weather Channel. Now, as you probably know, the Weather Channel provides same day out to 9-day ahead forecasts, and they give forecasts at the 0.1 level. So they'll say 10%, 20%, 30%, and so on. And you either get their forecast from their cable network, which reaches almost 100 million households, or from their internet site, which has over 20 million unique users per month. So they're a very important provider, large provider of weather data, weather forecasts to the public. And the question is, well, how accurate are these forecasts? Are they free from bias or not? And so we worked with them. We analyzed over 13 million probability forecasts covering a 12-month period. This was back end of November 2008 into October at 800 locations across the United States. And we looked at 3 different forecasters. We looked at the National Weather Service, the Weather Channel, and Custom Weather. And across 800 locations in the continental United States over an entire year, and that's how you get up to this 13 million probability forecasts that we looked at. And then we got the observations at these 13 million, for these 13 million different events, and we could compare them. Okay. The National Weather Service is really the foundation of the weather forecasting system in the United States. And the Weather Channel relies on their forecasts as a starting point. And the National Weather Service divides the US, continental US, up into 9 climate regions, which you can see here in the map that I have. So I'm sitting here in the South, which would includes these states. And that's important because later we can talk about how we might improve their forecasts. And I'll show you how to do that. And I've broken that out by climate region. Okay, so here's the results for the Weather Channel, their calibration plot. This is 1 day ahead. So you get up in the morning and you look at what the weather's going to be tomorrow. This chart summarizes about 1 million probability forecasts, or POPs, probability of precipitation. And just like we had before, I have their forecasted POP. What did they say? And then on the vertical axis, we have what actually happened. What was the relative frequency? Okay, and if you look here, certainly from 0.5 to 0.9, they're really doing pretty well. This 45-degree line, this diagonal line, is perfect calibration. That little blue area around it it's an error band. It has to do with how much data there is. And if there's a lot of data, then we cut them a bit of slack. But because there's 1 million forecasts here, this error region is really pretty small. So you can see when they say 60%, it precipitates about 63% of the time. When they say 70%, it's a little bit more than that. Okay, but really pretty good. When they go up to 100%, obviously it doesn't rain 100% of the time the next day, so they're not well calibrated in that case. The little circles are ones where I was calling out if it's not well calibrated because it's outside of that error band, but really it's pretty good. Where they don't do so well is on these lower probabilities. When they say there's a 20% chance of precipitation, it only precipitates about 8% of the time. When they say 10%, it's about 5% of the time, and so on. And so down here, they are over forecasting. They're saying there's a 20% chance, but it's not really a 20% chance. It's something less than that. And this is one of the things that Nate Silver picks up on in his book. And what's going on here, when I showed this to the Weather Channel, they had never looked at their accuracy of their forecasts. When we pull this up, they said, yeah, that's because we're worried if we tell people there's only a 20% chance of precipitation, they'll leave the top down on the convertible that day. And then if it does rain, then they're going to be mad at us. So they're worried about how people are going to interpret the forecast. They're building in their thoughts about our decision making into their forecast. Okay, and so that degrades their performance here. This horizontal line is something called no resolution, which means if their performance was just a horizontal line across here, it would mean no matter what pop they give, it's the same observed frequency. So that would be really bad, a horizontal line. This line in between is called no skill. This has to do with essentially how good could you do if you just use climatological averages. And we can assign a skill score to forecasters. And in this case, the Weather Channel has skill. They are reducing your uncertainty about the weather over what you could have had just from climatological data. So they're adding value in that sense. Okay, so we don't want to be on this other lower diagonal line or this horizontal line. Now here's the data or the results for 1 to 9 days for the Weather Channel. 1 day ahead, this is the plot I showed you before, just a smaller version of it. 2 days ahead, 3 days ahead, down here to 9 days ahead. And again, you can see, in this region here from 0.4 to 0.9 in the near term, they're really pretty good. They're well calibrated. On this low end, they are over forecasting and they're not well calibrated there. But then by the time you get out to 9 days, their performance has degraded quite a bit to the point where they're actually below the no skill line here. And meaning they have negative skill, meaning they're increasing your uncertainty about the weather. Okay, this far out, you'd be better off relying on climatological data. So let's do a poll question here. So you see how they get worse, their calibration gets worse as you move out. My question is that reasonable? Is it reasonable for the Weather Channel's calibration to decline as they try to forecast further into the future? Okay, and we're going to open that poll, and the answer would be yes, no, or I'm not sure. So the question is, should their calibration get worse as they move out into the future? Okay, answers are coming in here. About a third of you, or 3/4 of you have voted so far. And we'll close the poll here shortly. Okay, you're looking at the results, and so about 3/4 of us, yes, that's reasonable. Their performance should degrade as we move into the future. And then 20%, no, it shouldn't get worse, and then a smaller group, not sure. Okay. Well, let's think about this. They're forecasting the probability of an event occurring. So here it's, will it rain in a day from now? Will it rain in 2 days, 3 days? Will it rain 9 days from now? Okay, and if you think about it, their calibration should not get any worse as you move out in time. Whether you say something that might occur tomorrow has an 80% chance of occurring, or something that might occur 100 years from now has an 80% chance of occurring, you should be well calibrated in both cases. So their calibration should not degrade as we move out in time. What should change as you move out in time is how often they give more extreme forecasts. Okay, and this is what this gray area is underneath that I haven't covered yet. So let's talk about that. I've gone back to the 1 day plot, and this gray region is how often they gave different pop forecasts. So you see, very rarely do they say there's a 100% chance of rain tomorrow. That makes sense because it doesn't always rain tomorrow. So they're saying that relatively infrequently. They're saying 80%, or excuse me, 20%, the most often. That again makes sense because that's about the climatological average. Across the US, it rains about 1 out of every 5 days. And so they give that forecast quite a bit. So what should happen as you move out in time, this gray region should become concentrated around the average. Okay, now here's a plot of that. Again, I'm repeating the results from 1 to 9 days. And what's interesting is if you look way out here, you see it's kind of strange. There's this peak at 0.6, and there's a real gap at 0.5. And so a couple points. One thing is these forecasts 7 days plus, they go directly from their weather models to the internet. And the performance, as we talked about here, is not very good. These should really be considered for entertainment purposes only. For 1 to 6 days, humans intervene in the forecast and they make it better. And so there were some questions about data mining and deep learning and so forth. At least at this point, humans are able to improve these near-term forecasts over what's coming directly from the computer models. But what's really interesting is it looks like they're avoiding 0.5, right? And they're saying 0.6 a lot and don't say 0.5 very often. So I pointed this out to them and they said, again, that's by design. because we're afraid if we say 0.5, people will think that we don't know what we're doing. It's a coin flip. It's either going to rain or not, so therefore there's a 50% chance it's going to rain. I think if you think about that, the question is, does that really make sense? Okay. I bought a lottery ticket on the way into work this morning, so there's a 50% chance I'm going to win the lottery. That doesn't make a lot of sense. And so they have a bias. Their forecast is biased. And the question is, what kind of a bias is that when they're avoiding a 50% chance? They don't want to say 50% chance. And the question is, why is that? And if we could launch that poll. What kind of bias is this? And there's three choices. I'll explain these. The first is a cognitive bias. A cognitive bias would mean there's just some kind of a defect in our reasoning that we're not able to get to the right number. We can't get to the right probability. A motivational bias would be we can get to the right number, but we don't want to tell people that number. Okay, there's some incentive that causes us to move away from that. Or the last would be not sure. Okay, so if you'd vote there, votes are coming in. About 80% of people have voted. Okay, and we'll close the poll here. And the results that I'm seeing here, over 90% say that this is a motivational bias. And yes, it is. It's a scary and a fantastic example of a motivational bias. They are building in their thoughts about our decision making and what we might think about them into their forecast. And they're also doing it in kind of a way that's even hard to defend, that because there's two outcomes, it has to be 50%. So this is sort of wrong on many different levels. And it really affects the quality of their forecasts. There's this peak at 0.6 and nothing at 0.5, and you can see just the ghost of that even in the one-day forecast. There's this little peak at 0.6 and higher than 0.5. Okay, just mention this quick, and we'll be getting towards the end. There's another company called Custom Weather. They forecast at the 0.01 level. So they'll say, for example, there's a 34% chance of precipitation, or there's a 35% chance of precipitation. And lo and behold, when they say something is 35 versus 34, it's more likely to precipitate when it's 35. It's not perfect. You can see it drops down occasionally. But by and large, they do have the ability to forecast down probabilities at that level. They do have a bias. They're not well calibrated, but we could fix that. Okay, so how can we adjust the forecast? And this is important, and this is something you're going to want to I think print out and keep on your refrigerator. What I have here is tables to recalibrate the Weather Channel's forecast. And what I'm showing here is a table. This is for the southern climate region. You can go to my website down here, and you can go to your climate region, and you can get the tables for your climate region. And there's two tables. There's a warm season and a cool season. I've only showed the warm season here. It's harder to forecast in the warm season because the storms are more localized, where in the cool season, it tends to be larger fronts that move through. And the way that you read this is you get their POP, their probability of precipitation, and you read across to that column. So for example, suppose they said 60% chance of precipitation. Then you look at the lead time. Okay, and so let's say they said there's a 60% chance of precipitation 2 days from now. Okay, well that really means 64%. Let's say they say there's a 60% chance of precip 4 days from now. Well, that means 35%. If they said that for 5 days from now, that means 29%. The dashes are where we don't have enough data. And so you can use this table for all your weather-dependent activities. My wife might want to be planning something for the weekend 5 days from now. She'll say there's a 60% chance of precipitation. My son will say, well, did you check the chart? Because 60% really only means 29%. So go to my website, you can print these out, and you want to keep these charts handy. Let me conclude with a business example. This is the same plot that I've been showing you, but this was put together by Jay Anderson at Eli Lilly. And they need to forecast the probability of clearing particular clinical trials. And Jay tracked this over 13 years for over 730 forecasts. And then he looked at how well they're doing. And he had to bend these somewhat. So for example, they might say 77%, they might say 82%. Jay bent all those and called that 80%. And then he looked at how well did they do, and over 164 assessments that were between 0.75 and 0.85, they were correct 80% of the time. Okay, and this little band here is the error band that Jay put around that, and you can see all of their forecasts fall within this band. So they are able to forecast these probabilities, and that's after some training that they're a very big proponent of decision quality and then decision analysis, which underlies that. But I think this is additional evidence that people can do this.
Awesome. Thank you, Eric, for bringing us your expert insights on the measuring of the quality of a forecaster. That was really interesting. So, Eric, the first question I'm going to go to is, how would you handle multiple forecasters? Is there some way of averaging forecasts, or how do you kind of look at that from that perspective?
Yeah, that's a really interesting question, and there is a way to take multiple forecasters and to weight their forecasts based on their performance over time, and then to combine those forecasts in a reasonable way. There's many ways to combine forecasts. Some are good ways and some are bad ways, and that's really a deeper discussion we'd need to have, and potentially we could talk about that on another webinar.
Awesome. Well, that's good fodder for follow-up webinars. And the other question I'll sneak in here is, how do you improve the accuracy of a forecast that only happens once or very, very few times, where you don't have so many data points?
Okay, yeah, that's challenging. So here, granted, we have a lot of observations and we can track that over time. So I'd say that two responses to that. One is the underlying methodology of how to assess probabilities, how to debias experts, how to do a probability assessment in the correct way. That applies whether you're assessing many probabilities or just one. And I think those methods are proven and really underlie the great performance like that Jay Anderson documented at Eli Lilly. So I think those foundational, how do you do this, applies in either case. There are some more technical ways to deal with forecasting either rare events or events that are unique, and it's a little, I can't really address it fully here. That could potentially be another webinar topic.
I love this idea, more webinars, more topics for us that people are interested in. That's great. That is we are getting close to the end of our time, so that is all the time we'll have for questions online. We will answer additional questions offline because there were quite a few more that we just were not able to get to today. And for now, I want to thank you, Eric, and also thank all of our participants for spending your time and energy with us today. We look forward to connecting with you again very soon. Have a wonderful day.